So I'm going to add to what we have been doing with simplifying and proving, and I gave you kind of a hint of where we're headed yesterday. In one of the homework problems that we went over, I asked you, hey, what was the definition I gave you of sine and cosine? And the definition, if this is angle theta, is sine is a side length of a right triangle across from the angle we're talking about with a hypotenuse of 1. Okay, and cosine is the length of the other side or the adjacent side of that or leg of that triangle adjacent to the angle we're looking at. And then from here, if we use Pythagorean theorem on this triangle, we get that sine squared theta plus cosine squared theta equals 1. And this is the first of 3 Pythagorean identities that I'm gonna be showing you today, and we're gonna be working with. Okay, and this one is the most popular and probably the most powerful one. And we kind of hopefully see exactly where it's coming from. It's coming from our definition using the Pythagorean theorem. That's why we call it a Pythagorean identity. Okay, and so let me show you a little bit of how this works. So if you have, say you're working through something and you see a problem and you're trying to simplify it, and it says 1 minus cosine squared theta, right? And you're kind of stuck and trying to say, well, can I simplify this anymore? Well, if you see a cosine with a squared, you can automatically think, well, can I use the Pythagorean theorem on this one because it's got a squared and it's dealing with cosine? What would happen if I solved, well, can I change this equation into 1 minus cosine squared? And so let's try to do a little algebra on this thing. So if I subtract cosine squared from both sides, I get sine squared theta is equal to 1 minus cosine squared theta, right? Those are the same equations, just changed around a little bit, right? Or at least the second one comes from the first one. And so from that we see, oh, 1 minus cosine squared theta, I could simplify that to what? Sine squared theta. Right? And that's the kind of thing that we're going to now have to look for when we're working through some examples. Let me give you another quick example. What if we had something like this? Sine squared theta plus cosine squared theta over sine squared theta minus 1. And I said simplify that. Can you guys see something we can do to this thing? Yeah. Man, that bottom one's a little trickier, but the top one's super easy. What's the top part going to be? 1. So let's do that. Let's do the easy part first. So 1 over sine squared theta minus 1. So we went from a more complicated fraction to a little easier one. Then the question is, can we, you said it's equal to cosine squared. Well, let's check. I'll check right here. So if I want to change sine squared plus cosine squared equals 1 to cosine squared, I need to subtract sine squared from both sides. And I end up with cosine squared theta is 1 minus sine squared theta. Is that the same thing as sine squared minus 1? No. Close, but not quite, right? It's just not the same. So could we take our Pythagorean identity here and manipulate it so it says sine squared minus 1 somehow, where the sine squared's positive and the 1's negative? Yeah. Yeah, so let's leave the sine here. Let's move the 1 to the left, and let's move the cosine to the right. And that would work, right? So I'd get sine squared theta minus 1 equals negative cosine squared theta. Right? So I moved the subtracted cosine squared from both sides. That made it negative cosine squared. And I subtracted 1 from both sides to move the 1 to the left side. And now it matches what I have here, sine squared minus 1. So what do I change sine squared minus 1 to? So this is going to be 1 over negative cosine squared theta, which becomes, what is it? Negative secant squared theta, right? And so this is the kind of, this is the new part. This is, we're just thinking, okay, sine squared plus cosine squared equals 1. And we can take different forms of that here, right? We can change that equation around a little bit, and that can help us through some problems. And so I'm going to give you a couple examples. There are 3 different identities, but I just want to work with this one. The more we get used to this one, the other 2 are going to just fall into place, okay? So here's example 1. Cosine squared theta over 1 minus sine squared theta. We want to simplify it, so I should write that. And so, ideas, Luis? Okay, you're giving me, we need steps in between though. We need some steps. The denominator? Okay, so you're using, okay, so we know sine squared theta plus cosine squared theta is 1, and so you solved for what? You solved for sine squared theta? Cosine. So you subtracted sine, and so you got cosine squared theta is 1 minus sine squared theta, which is what we have there. And so we got cosine squared theta, and then we substitute in another cosine squared theta, and that's 1. Good. Very good. Everybody see where that's coming from? Okay. Let me give you another example. Here it is. Example 2. Again, I want you to simplify. Okay. Easiest thing we can do to this problem, Kaya? So you could split it into 2 fractions? Is that what you're thinking? We could, but there's something easier than that. That's just 1. Hold on there. Oops, I'm messing up. Let me catch up to you. You see that, Kaya? So, although we could split it up into 2 fractions, this would be preferred. If you can do this, if you see that sine squared plus cosine squared, that trumps the splitting up into two fractions. Go ahead and do that one, okay? And then, yeah, go ahead. Okay, so let's see why that is. So we know sine squared plus cosine squared is 1. That's our identity. And we want to make a cosine squared minus 1. So what we're going to do is we're going to move the 1 over this way, and we're going to move the sine over this way by subtraction. We end up with cosine squared theta minus 1 is equal to negative sine squared theta. And that's what you're talking about, right? And so we can go further. So 1 over negative sine squared theta, which is negative cosecant squared theta. And we simplified it. So keep an eye out for whenever you have the squareds, the sine squared, the cosine squared, keep an eye out and ask yourself, will this Pythagorean identity help you at all? Yeah, question? What's the long way? So without the Pythagorean identity? I don't think so. You can try, but I think you'll get stuck. I think you'll get stuck on this one. There may be some problems where it will work, but on this one, I don't think so. Okay, here's 5 sine squared theta, 5 cosine squared theta. We want to simplify that as much as we can. Any ideas what to do on this one? Yeah, what do you think, Elijah? Steps is what I want. Fractions. What fraction? You change like that. Okay. How do you move the 5s though? It's like the 5s are in our way, right? We see the sine squared plus cosine squared, and that's what we want, but those 5s are in our way. Yes. Factor. There we go. That's what we want. Factor the 5 out. So 5 times sine squared theta plus cosine squared theta. That's why we factor to move it out, right? And now, what's sine squared theta plus cosine squared theta? 1. So this is 5 times 1, which is 5. Okay? All right, next example is a proof. And I want you to prove that sine squared 2x minus cosine squared 2x is equal to 2 sine squared 2x minus 1. All right. First thing I want to say about this is don't let the angle intimidate you. So the 2x is the angle, right? So that doesn't change. That's okay to be there. It's just an angle. All that matters is that the angle's the same. And all the angles are the same. They're all 2x. They can all be a y. They can all be a z. They can all be a theta. Doesn't matter. Okay, so ignore that 2x. So really this should read in your head sine squared minus cosine squared equals 2 sine squared minus 1. Okay? So ignore the 2x. We're going to have to carry it along with us, but it has no impact on the problem. Okay? Now we're proving, so our goal is to make the left side look like the right side, and we can't touch the right side. Okay, that's the goal. Can't touch the right side. What does the left side have that the right side doesn't have? The left side has a cosine, right? And the right side doesn't have a cosine. So we know we have to get rid of the cosine, right? And so that's our focus. Can we get rid of cosine squared? Or can we replace cosine squared with something that's equal to it? So think Pythagorean identity. What's cosine squared equal to? You following what I'm doing here? Here's your Pythagorean identity. Sine squared of, we'll use 2x plus cosine squared of 2x is equal to what? 1, right? That's our identity. And so if that's true, then what would cosine squared of 2x equal? You have to move the sign over to the right? Equals 1 minus sine squared of 2x. You see where I'm getting this from? Ignore the 2x. Don't let that throw you off. That's just an angle. Okay? So, in my proof, okay, I'm going to change colors here so we know that we're working with the proof. I'm going to write sine squared 2x, right? Minus, and I want to get rid of the cosine squared. And so when I get rid of the cosine squared, I put what? 1 minus sine squared 2x. But if I do this, I made a mistake that a lot of people have a hard time seeing. Simple mistake. But if I continue on from here, I'm not going to get it equal to the right side. Yeah. You have to put parentheses around this whole thing because there was a minus sign in front of that cosine. And that minus sign needs to distribute to both pieces. And it's just easy to forget that, but don't forget that, okay? So distribute that negative next. You get sine squared 2x minus 1 plus sine squared of 2x. You see how to finish this? What do we do? Add the signs together. They both match. So if I have one here and one there, and I add them together, I end up with 2 of them. And we finished our proof. Okay. So that's what the sine squared plus cosine squared equals 1 adds to our plate there. Okay. Now I said that there were actually 3 Pythagorean identities, not 2. So let me introduce you to another one. It actually comes from sine squared plus cosine squared. And to tell you the truth, I don't have the other 2 memorized because I know how to get them from this one. You can memorize all 3 or you can know how to get all 3. Okay, this is the only one I memorized. And here's how I know how to get the other 2. So if I want one of them, I'm going to take this and divide everything by sine squared. If I do that, and I get one of my identities. So what's sine squared divided by sine squared? 1. What's cosine squared divided by sine squared? Cosine over sine? Cotangent. So 1 plus cotangent squared theta equals, what's 1 over sine? Cosecant squared theta. So that is our second identity. Okay. And so now we have that one. We got to look out for that one as well, right? So let me get the next example ready for you. What were we on? Example 5 now, right? So here we are. So we want to simplify this. 1 minus sine squared x over 1 minus cosecant squared x. So think about the two trig identities now. We have the sine squared plus cosine squared equals 1, and we have the 1 plus cotangent squared equals cosecant squared. And have those help you to simplify this. So write this down and see if you can maybe take a step or two in the right direction. So I'm going to write the other one here. Sine squared x plus cosine squared x we know is 1. How can we use that one right there to help us with the top part? Subtract sine. So we're going to take the sine, subtract it, and we end up with cosine squared x equals 1 minus sine squared x. Okay? And so now over here in our fraction, we can make the top part cosine squared x. Okay, that's nice. 1 minus cosecant squared. So I'm not going to use sine squared plus cosine squared because there's no cosecant in that, right? I'm going to use the 1 plus cotangent squared equals cosecant squared, right? And I'm going to ask, in that equation, is there a way to make 1 minus cosecant squared x? Yep. Move them around a little bit. And we end up with 1 minus cosecant squared theta, I guess, is equal to what? Negative, good job. Negative cotangent squared of theta. So here we have x, not theta. So negative cotangent squared of x. And then once you get out of that, now we're back into the simplifying that you have been doing for homework for the last 3 days. So what might we want to do next? Move the cotangent up, great idea. And that negative, when you move that up, just keep it in front of stuff. So negative cosine squared x times tangent squared x. And then another good step, maybe get everything in terms of sine and cosine. So negative cosine squared x times sine squared x over cosine squared x. Simplify. And our answer, negative sine squared x. So we were able to take that whole fraction and simplify it down to negative sine squared x. How you doing? Doing okay? All right, I have one more example and one more trig identity. And actually, if you're following what I'm doing, you probably already know what the next trig identity is. If not, that's okay. I'm going to give it to you. So it starts from sine squared theta plus cosine squared theta equals 1. And to create the second one for you, what did I do? I divided everything by sine squared. But on this one now, I'm going to divide everything. You're jumping ahead of me. On this one now, I'm going to divide everything by cosine squared, and it's going to create the third identity that we want, and it's the last one too. So divide each of these by cosine squared. And what's this new identity going to look like? Tangent squared theta plus 1 equals secant squared theta. And so that is the third one and the last one that we're going to need to know. And so I have one last example. Here it is, grand finale. We can do this. Brackets and parentheses are the same. Oh man. So, to be continued. But you have enough for homework, all right? You can do your homework. Homework is easier than this. Oh, hold on to this. I haven't had time to go this out. The answer, you want to see it? I'll show you last periods. There.